Many of you have asked to have some help on this PERT question. It's the extended response from the 4, 9, and 13-week assessments, the first extended response. In this particular problem, it's from the 13-week. Explain how you'll find the rate of depreciation if your rental property, which was worth $2,243,359 at the beginning of the zombie apocalypse, so that's your starting amount, had fallen to $872,699,000 in the endless 12 years that it took to find a cure and end the horror. Endless means we're talking continuous depreciation. It's fallen endlessly in 12 years. So we have to use PERT. Now remember PERT, let me see here. When we say use PERT, you might see it spelled this way in problems. What it really means is that you're using y equals p times e raised to the RT, where y is your ending amount, p is your starting amount. So p is going to be 2 million, etc. Y is your ending amount, 800 whatever, thousand. E is just a number in your calculator. R is that rate of depreciation we're trying to find. It's going to stay in R. And the T is the time in years here, 12 years. So to fill these numbers in, when you explain, you have to verbally explain what you're doing to plug into this formula to solve and how to solve it. Then we're actually going to find the rate of depreciation. Let me show you how to do that exactly. So if I plug in the starting amount for my property, that 2 million number, and my ending amount, Y, for my property, the 800,000 number, T is 12, E is a number that stays in the formula, then my formula turns into 872,699 is equal to 2,243,359 times E raised to the rate that I don't know times 12, so 12R. The very first thing you need to do is to divide both sides by 2,243,359. Cancels it out right here. So you get this fraction equal to E raised to the 12R. Well, how do you get any variable? Remember your variable is R here. E is a number in the calculator. How do you get any variable out of the exponent? You log both sides. But since this is a base E, we use a special log, the natural log. And we have to natural log this fraction that I didn't write down and natural log E to the 12R. When you do that, let's write this out. We get, oops, come on, nope, ln of the fraction, I'll actually write this time, 872,699 over 2,243,359 is equal to the ln of E raised to the 12R. And when you have an exponent inside a logarithm, that exponent drops down out front. Move up, hold on one second. So if I have to move this exponent down out front, that becomes 12R times ln of E is equal to the ln of this giant fraction that I'm not going to write for a second here. And also remember the ln of E. The ln of E is equal to 1. So 1 times 12R is just 12R. 12 times the rate, 12 years times the rate is equal to ln of this fraction. How do you get R by itself? We divide both sides by 12. So you divide the ln of that fraction by 12. This will give me R. It gets R by itself because the 12s cancel out. I have R by itself now. So exactly R is equal to the ln of 872,699 divided by 2,243,359 divided by 12. Put that in your calculator, and guess what you get? Negative 0.0786, and it just keeps going. That decimal just keeps going. Move this up, hold on. This is the R value that you would use in the formula. Negative means depreciation, and decimals are moved over 2 places from where they started in a percentage. So you can't just leave this answer like that. The rate of depreciation is a percentage of 7.86%, and that negative tells me to say that it's a depreciation or decay. That's your best and final answer. Good luck.